day, students. Welcome to today's lesson on a very important topic in algebra called the laws of indices. Sometimes you may also hear it called the laws of exponents. These laws help us simplify and solve expressions that involve powers, especially when variables appear in the exponents. Okay, let us take a moment to think. When we see numbers like 2 squared, 2 cubed, or 2 to the power of x, we are working with indices. The laws of indices give us clear rules for multiplying powers, dividing powers, and raising powers to another power. Without these rules, solving complex equations would be very difficult. In grade 12 mathematics, you will often be given equations where the bases look different at first, like 2, 4, and 8. But students must remember, these numbers can be rewritten in the same base. Once the bases are the same, we can apply the laws of indices correctly and solve the equation step by step in a logical way. Some key laws we will use today include the product of powers rule, the power of a power rule, and the rule that when bases are equal, the exponents must also be equal. Okay, these are standard rules that you must always keep in mind when solving index equations. Now, students, we will solve this equation in 7 steps. Let's read the equation carefully. We are given 2 to the 3x plus 1 times 4 to the x minus 2 equals 8 to the 2x. Okay, notice something important here. The bases are different. We have 2, 4, and 8. This means we cannot compare the exponents directly yet. We are going to solve this problem in 7 simple steps. Follow along. Step 1. First, we express all numbers in the same base. Remember, 4 is equal to 2 squared, and 8 is equal to 2 cubed. Good. Now everything can be rewritten in base 2. Step 2. Next, we substitute these values into the equation. So the equation becomes 2 to the 3x plus 1 times 2 squared to the x minus 2 equals 2 cubed to the 2x. Now the bases are consistent. Step 3. Now we apply the power of a power rule. Okay, recall the rule. A raised to m raised to n is equal to a to the mn. So, 2 squared raised to x minus 2 becomes 2 to the 2x minus 4, and 2 cubed raised to 2x becomes 2 to the 6x. Step 4. Let us rewrite the equation after simplifying the exponents. It becomes 2 to the 3x plus 1 times 2 to the 2x minus 4 equals 2 to the 6x. Notice how we simplified carefully, step by step. Step 5. Now we use the product of powers rule. When multiplying powers with the same base, we add the exponents. So we add 3x plus 1 and 2x minus 4. This gives 5x minus 3. Therefore, the equation becomes 2 to the 5x minus 3 equals 2 to the 6x. Step 6. Observe carefully, students. Both sides have the same base, which is 2. According to the law of indices, if a to the m is equal to a to the n, then the exponents must also be equal. So we equate the exponents. 5x minus 3 equals 6x. Step 7. Finally, we solve the linear equation. Subtract 5x from both sides. That leaves negative 3 equals x. So the final answer is x equals negative 3. Excellent, students! Remember, the key steps are to rewrite the bases the same, apply the index laws carefully, Simplify the exponents and then solve the resulting linear equation. Take your time to understand each step. That is how you master the laws of indices. Now let's solve question 2. We're given 5 to the power of x plus 2 equals 625. We will solve this in 7 steps. Step 1. Recall the power rules. First, let's remember some important power rules. Rule 1. When we multiply the same base with different exponents, we add the exponents. That is, a to the power of m times a to the power of n equals a to the power of m plus n. Rule 2. When we divide the same base with different exponents, we subtract the exponents. Rule 3. When a power is raised to another power, we multiply the exponents. And finally, any number to the power of 0 equals 1. These rules will help us solve this equation. Step 2. Express 625 as a power of 5. Now, let's look at 625. Can we write 625 as a power of 5? Yes, because 5 times 5 is 25. 25 times 5 is 125, and 125 times 5 is 625. So 625 is the same as 5 to the power of 4. This makes the equation much easier to solve. Step 3. Rewrite the original equation with the base 5. So 5 to the power of x plus 2 equals 5 to the power of 4. Notice how now both sides have the same base. This is perfect because it allows us to use the equality of exponents rule. Step 4. Apply the equality of exponents rule. Now remember that if the bases are the same, then the exponents must be equal. So we can set x plus 2 equal to 4. This gives us a simple linear equation to solve for x. Step 5. Solve for x. Next, we solve for x. Subtract 2 from both sides of the equation. So x equals 4 minus 2, and that gives us x equals 2. Step 6. Check the solution. It's always good to check our answer. Substitute x equals 2 back into the original equation. 5 to the power of 2 plus 2, which is 5 to the power of 4, and that is indeed 625. Perfect! The solution is correct. So, students, our final answer is x equals 2. And that is how you solve 5 to the power of x plus 2 equals 625 using the rules of indices. Remember, always express numbers as powers of the same base whenever possible. This makes solving exponents much easier.